Okay, today we're going to look at the current and voltage through an injector on the Chevy Cruze. It's pretty similar to most any other car you're going to look at. Each injector has 12 volts fed to it from a common source. So on this schematic, one is going to be 12 volts on each injector. So if you were to scope that, all you would see is a 12 volt signal if it was operating good. The one we're going to look at is we want to be in number 2 because we're going to look at what happens when it gets switched on and off. And one of the things that you need to know is if we're looking at a coil that collapses and turns back on, we're going to need to use an attenuator. I'll explain that in a little bit here. We're going to also look at amperage, and because it's a series circuit, all we have to do is wrap our amp clamp around either lead. It's already got a pattern on this car. I'll show you how it's hooked up right now. I've got one probe into the ground side of the coil or injector, and I've got my amp clamp around the injector. Amp clamp doesn't matter. Because this is a collapsing coil, we're going to need to stick an attenuator in line with our reading because this scope is only good for 20 volts. And a collapsing coil, you'll see over 100 volts in some cases. So it'll smoke your scope if you don't watch out what you're doing. So it is somewhat important because you have to tell the scope you're going to use it. So when you set up your scope leads, the first one you're going to have to tell the probe that you're using standard and a times 20 attenuator, and then your readings will come out all right. On amped, you're going to have to go into probes and you're going to have to tell it you're using the 20 amp clamp. If you notice, I've got the voltage set at 100 amps, and we've got 5 amps on the current, 5 milliseconds. And what I've put is a trigger in here so I can get a good pattern. And so what these patterns show us is we're basically looking at the voltage to this injector. And if you look at it, it's about what battery voltage is, probably about 14 and a half as we're running this thing. And as soon as the injector shuts off, it should drop to 0. Or when the injector turns on, it's going to drop to 0. If it doesn't drop to 0, that would be an indication that we've got some sort of resistance in our ground. So this is what is called on time. The injector's on. And then when we shut it off, you can see this spike of current. We're almost at 80 volts. And as we come down, you can see the pintle in the injector close, and we're back at battery voltage until we need another injector fire. The lower one is our amperage, and you can see that it's at 0 when the injector is off. As soon as we turn the injector on, it starts ramping up, and we can see that it's probably about an amp. And as soon as we shut the injector off, it drops down back to 0.